Our next speaker needs no introduction whatsoever. He is highly known and quite visible and quite outspoken on both the national and the international stage. General Bogdan, you have the floor.
Good afternoon. Thank you for having me here today. I will not kill you with PowerPoint. I only have about 3 or 4 charts just to make a few points. What I'll do is I'll talk for about 15 or 20 minutes, kind of give you a perspective of where the program is, and then I'd probably like to spend some time answering questions. Answering questions is always a good thing because I get to get the pulse of what people are thinking and potentially leads me into attempting to squelch rumors, innuendo, inaccurate things, because those seem to surround this program no matter what happens. So let's start in. I have one primary chart, and it's going to be that one, and then I'll jump off on a few others. So a few years ago, I would have told you that the program was making slow and steady progress. Today, the program's a little different than that. We've kind of hit a turning point on the program over the last 18 months or so, and slow and steady progress is still a good thing, but we are really transitioning. We're getting bigger and growing, and we're accelerating in some areas. So we've gone from that slow and steady, and let me talk to you a little bit about 3 of those major areas of the program that I'm talking about. So the big development part of the program, we call it SDD, valued at over $52 billion, started in 2001, is rapidly coming to a close. We think by the end of calendar year 2017, all the major tasks under the SDD contract, minus a lot of the closeout stuff and the paperwork stuff, are going to be done. In fact, we believe that the flight test, which is the major portion of what's remaining, is probably going to be done in the summer to fall timeframe of 2017. So we're faced with a situation now where we're coming off this very, very big, very, very expensive SDD program, and we're attempting to transition into what I call a much leaner follow-on modernization program. We have to have a follow-on modernization program because the threat doesn't stop, okay? And we have to keep this airplane viable for the next 30, 40, 50 years. So you've got to start that. So my program office and industry today are working on how we can transition that very big program into what I call a leaner follow-on modernization program. We think that program in earnest from a contracting standpoint will start probably in 2018. From now to 2018, what we're doing is we'll go through the AFROC, the Air Force Requirements Oversight Council, and the JROC, the Joint Requirements Oversight Council, this spring and this summer, and we will nail down the requirements for what we call our Block 4. That's the next 8 to 10 years from now until about 2025 with those requirements. We are already on contract with a few of our primes to do some requirements analysis, to do some breakdown of those requirements into the lower tiers, and we believe with the requirements set through the JROC and through my partners on the program and having those low-level contracts in place, we're going to try and achieve what we call a preliminary design review in 2018 before we go to the department and ask them to sign off on the bigger follow-on modernization contract. That's kind of in line with the 5000.02 that said, you know, before you start major programs or major developments, you ought to get to at least some kind of maturity level with a PDR to know what you're doing. So we intend in early 2018 to go through a PDR for at least the first 2+ increments of Block 4. We'll present that to the department and then see if we can move into the follow-on modernization phase of the program. The budget's been laid in for doing that. Like I said, we've got to get the requirements done. We're working on the final tweaks of the acquisition strategy to do that. But we're looking to try and bring that big SDD program to a close and moving on into what I would consider to be a much more affordable follow-on modernization program. In terms of growing on the program, production is at the takeoff point. Let's go to the next chart there. So what you see right there is last year's production quantities, but you can see we're in the middle of negotiating Lot 9 and 10 with Lockheed Martin right now. We completed the negotiations with Pratt & Whitney on lots 9 and 10 for the engines, and have a handshake there, and we'll finalize those contracts probably this month. But you can see beyond lot 9 and 10, which we're working on right now, lot 11, 12, and 13, you see a big up ramp. Just to give you kinds of numbers right there, because the scale is not that good. In lot 12, we're talking about 145 airplanes. In lot 13, about 162. And then it kind of levels off, and we stay at about 160 to 165 until we get out, where some of our FMS customers and a few of our partners start really ramping up beyond 2021 to a point where we're about 170 airplanes a year, steady state out there. So you can see the production is rising up. The other line on that chart is the cost curve, and you can see it's coming down. The promise that we've made, industry and I have made to the enterprise, is that in 2019, an F-35A model with an engine, with contractor fee on top of it, in then-year dollars, is going to cost $85 million or less. We're on track to do that. We are on track to get to get an A model down below $85 million for a whole bundled deal. And 9 and 10 will follow lot 7 and 6, 7, and 8 with decreases in price as we've seen in the past. We're building airplanes right now in 3 different places. Okay, we built most of them in Fort Worth. We actually built our first airplane in Cameri, Italy, and flew it. It's now here in the United States doing EEE testing at Pax River. But we built that airplane and flew it over here about a month and a half ago. We are in the early stages of putting pieces and parts together at Nagoya to build airplanes for the Japanese in that factory. We talked about the prices coming down lot over lot. There has been a lot of noise in the system about the Air Force changing and deferring airplanes out in the FYDP. So I want to, from a holistic program perspective, give you the impact of that. So the Air Force in their last POM reduced 42 airplanes. Okay, and they did it for budgetary reasons, not necessarily programmatic reasons. But in that same time frame, just to let you know, the Navy and the Marine Corps plussed up 21 airplanes. Okay, and if you assume that eventually there'll be other FMS customers, and I can tell you today there probably will be in that 5-year period, the overall effect of the Air Force deferring those 42 airplanes is barely measurable. The number I have here tells you that over the 6 years from 16 to 21, we were going to build 893 airplanes. Now we're going to build 873 airplanes, and that does not include the FMS customers that I just talked about. We're not booking those yet until we know we've got them. So overall, through the Navy and the Air Force's moves, we're only losing 20 airplanes on a base of about 893 over 6 years. I can barely measure the price change of the airplane for that decrease. And like I said, if the FMS customers come in the way we think we are, we'll actually be above 893. So there's been a lot of question on the Hill and folks about the death spiral. You know, you start buying less airplanes and the price goes up, and when the price goes up, you can buy less airplanes in the future, and so you buy less airplanes and the price goes up. That is not going to happen on this program. It hasn't happened on this program, and there's simply, I do not see a scenario for that ever happening. Part of the reason is because look at the green box. The green box are our partners, okay, our partners and FMS customers. And in the out years, they constitute almost 50% of this buy. Many of them have already had their governments agree to buying that number of airplanes and have the money in the budget. So unless something radical changes, I don't see the program moving into any kind of death spiral like that. I'd like to just mention very, very briefly, we are looking at a block buy on the horizon. A block buy is very similar to a multi-year. In fact, from practical terms, it's almost exactly the same. From statutory and from the things that I have to do to get it through the department and through the Congress, they're different. But from a business perspective, a block buy and a multi-year are virtually the same. We, the JPO, the program office, would like to try and do that in lots 12, 13, and 14. Unfortunately, the budget needs of the services and the timing of our request to have that money pulled forward for the services to start in lot 12 was too hard to do. So the department is committed to trying to start, at least for the services, the block buy in lot 13. But I still have FMS customers and partners who are very willing and want to start that block buy in lot 12 because the total savings in just those 3 years between lots 12, 13, and 14 are well in excess of $2 billion for the whole enterprise and all the partnerships, and that's a conservative number. So there's no reason why we couldn't structure a business case that allows the partners and the FMS customers to start a block buy in lot 12, and then when the services are ready and have that upfront money for the EOQ that they'll need, we can bring them in lots 13 and 14. That diminishes the savings a very little bit, but I would tell you not enough to really defer our other customers from wanting to do that. So we're trying to sort out how we would get that done, if that indeed is what we have to do. Let's go back to the main chart. Talking a little bit about fielding and sustainment, that's where we're accelerating. We're getting big really fast. So let's go to the next chart there. So that's obviously a picture of the globe. All the black locations, those are already stood up. All the red locations, that's what we're going to do in the next 4 years, either standing up repair capabilities or putting airplanes in country in those locations for our partners and our FMS customers. So we are very rapidly and quite quickly accelerating the footprint of the F-35 globally. One of the things that my program office and industry is concentrating on right now is making sure that we can repair and sustain all those airplanes globally. So we're developing a global supply chain. We're developing heavy maintenance capabilities in both the Pacific and Europe to complement what we've already done in North America. And the purpose of that is so that when you have component repair or heavy maintenance repair for airplanes in the Pacific theater, you don't have to drag them all the way back to North America to get them done, nor the same thing with Europe. You don't have to drag them back. So we're going to try and replicate some of that capability in the Pacific and in the European regions. And that's a key component of what our partners and FMS customers are looking to do in the future in terms of their industries. And the department has a process to ensure that if that work is going to be placed in the Pacific or the European region, that we look to the partners and the FMS customers and their industries to do that work for us. A few years ago when we started flying, the airplane did not have very good aircraft availability rates, or what we call MC, mission capable rates. I would tell you from these numbers here, we're getting a lot better. We're getting a lot better. Aircraft availability is how many airplanes are available to the warfighter to fly on any given day, because many of them could be in depot or in mod in this case. And of the airplanes that you have on the ramp, mission capable rate is how many of those airplanes are fully capable on that given day to go out and fly a complete mission and check off everything that the pilot wanted to do on that mission. So you can see the trend there. We plan on continuing to try and improve aircraft availability and mission capable rates by driving down our supply chain times, our repair cycle times, the time airplanes spend in mod, how long it takes maintainers to fix airplanes. All those things build into your aircraft availability and your mission capable rates, which in the global picture is called readiness. And so we're committed in the JPO and with industry to drive the readiness of this airplane up to what the warfighters expect from us. Okay, let's go back to the main chart. The weapon system design is stabilizing. We have about 80% of all flight testing done now. We have 20% of the flight testing to remain, and about 20% of all the tasks in SDD remaining for the next 2 years. We also have what we call component qualification. So each component and part and system on the airplane has to be, quote, fully qualified from the vendor, and then the airworthiness authorities and the services have to give it that thumbs up. 98% of all components on the airplane and all systems on the airplane today are fully qualified. We'll finish that up in the next year and a half. So relative to the design of the airplane, major changes is what we measure in terms of structural changes and things are on a slope such that by the time we get to about mid-2017, we're down to estimated no major changes on the program. So we think that the design is coming along pretty well and stabilizing pretty well. The first set of airplanes that roll off the production line that will have the full hardware and software capability for the final version of the F-35, we call it 3F, start coming off the line in Lot 9, okay, which we're negotiating right now, which is about 2 years from now. So we anticipate that by the middle of 2017 and early 2018, we will, off the production line, be delivering airplanes that meet the full capability of what we promised in SDD. Costs are pretty stable. I look at the program in three major cost areas. Our SDD, or RDT&E budget, our research budget, pretty stable since we rebaselined in 2011. I have not gone back and asked the enterprise for any more money to finish SDD, and I don't intend to. We have enough money in the budget and in management reserve to finish SDD with the money that we have. We just talked about the procurement costs continue to come down lot after lot after lot. Lot 8 was about 4% cheaper than Lot 7. Lot 7 was about 3.5% cheaper than Lot 6. I'll tell you, Lot 9 and 10 are going to follow the same trend, and we believe, again, by 2019, we're going to be down to about an $85 million or lower priced airplane. The last cost is the O&S cost that we always worry about. You're going to see later on, I'm going to talk about that crazy $1 trillion number again. That number means nothing to me. The 60-year life cycle cost estimate of the F-35 actually means absolutely nothing to me. What I care about today is, what am I doing to drive the cost per flying hour down, the maintenance costs on the airplane? What am I doing today to get those costs down? There are so many assumptions you have to make on a 60-year estimate that number for you and I'm not sure what we'd ever do with it. So that's what we care about. And what we are seeing is, through our reliability and maintainability program, through our initiatives with Alice, through our initiatives, what we call operationalizing the F-35 with our maintainers, we are seeing the maintenance man hours come down. We're seeing the time between sorties to regenerate sorties coming way down. We're seeing the time between failures on pieces and parts and repair times coming down, and that all leads to lower O&S costs. So we are on a good trend there also. That's not to say that we don't have problems on the program. It's a really big and complicated program, and there are always things that are going to show up. Alice is always at the top of the list. It's a very software-intensive system. It's got like 16 million lines of code in it, and it touches every part of the weapon system. It touches maintenance, it touches logistics and supply chain, it touches maintenance training and pilot training, it launches airplanes, it's configuration management, it touches all aspects of the program. And what I can tell you is it is very complicated to improve the capability of Alice with all those different modules in there at the same time, because they all have to work together and talk together. So you got to bring the whole system up basically together to get that. And what we found is that's a lot harder than we think, okay? It doesn't mean that from a technical standpoint we're not going to get that done, because I'm pretty confident we are. It just means from a schedule standpoint, probably going to take a little bit longer than we expected. I've been telling the Air Force that their biggest risk to IOC is the next version of Alice, that they are going to need to declare IOC. The promise was to get it by 1 August. I'll tell you there's probably 45 or 60 days of risk in that schedule, and I'm not sure that risk can be mitigated. We're going as fast as we can, industry's going as fast as they can, but I'm not 100% sure we can make up that time. We'll know as we get closer this spring and this summer, but I'll be the first one to stand up and tell the Air Force that and apologize to them, because we promised 1 August, even though they have a 1 August to 1 December time frame. We were focused on 1 August, and if we can't make that, we won't be able to make it. Mission system software is always hard and tricky. Right now we're dealing with some stability issues with the system, and that's because as we added more capability to the radar and to the other sensor systems on the airplane, the timing between the messages on the software between the sensor systems and the main computer doing fusion were not exactly aligned. And these little time differences in nanoseconds build themselves up on each other, and then you get to a point where the messages are out of sync. When that happens, either the radar shuts off or the EOT shuts off or the dash shuts off. They recover themselves, but that's not what you want to have happen in flight, because in some instances with the radar, when it shuts down, it takes a few minutes, to come back and get you to the clear picture again. The good news is we found the root causes in the lab. We're getting ready right now in the end of March and early April to put those fixes in our software and fly it on our flight test airplanes. If those fixes work, then I will tell you we'll roll those fixes into the software that the Air Force is going to use for IOC, and it won't affect the IOC date of 1 August. We'll take those fixes and we'll also roll them into 3F, our latest version of software, and then we'll move on for the program. All this extra work, though, has put a risk to finishing the 3F software on time. And I still stand here today, just like I did last year, and tell you there's about 4 months of risk in when we think we'll finish flight testing with 3F software to what the IMS schedule says it will be. We're trying to mitigate that as best we can, but until we get past this stability problem, I can't give you a clear indication of whether any of that 4 months of risk is really going to be realized or not. Aircraft mods are a big deal. I'm going to have over 350 airplanes coming off the production line or in the field in the next year and a half that at some point in time will have to have major mods done to them. That's the world of concurrency on the F-35 program. And there's nothing you can do about it. You just got to work through it. You got to get a mod plan. You got to work with the services and the depots and industry to get the kits right and to get the airplane availability right. And then you just got to get them into the flow plan and do the mods. But we will be doing mods on this airplane for a number of years before we get to that final 3F configuration for all the airplanes that we've already fielded that don't have all the hardware and the software that we need them to have. The issue with our reprogramming labs is simply throughput. Today we have one reprogramming lab. They build a mission data file for the airplane, kind of the information about the threats and the AOR and the friendlies, and you put that in the airplane, and that's kind of feeds the brains of the airplane. We only have one lab right now that's producing those mission data files, and that's down at Eglin under the control of Air Combat Command. In the future, we'll have 4 of those labs up and running in about the next 2 to 3 years, some for our partners, some for our FMS customers, and this one uniquely that's working right now for the U.S. services. But that one lab right now is trying to service all our customers. Everybody that needs an MDF in the next 2 to 3 years, including, for example, Israel, who will have their airplanes delivered in country in December, that USRL, that United States Reprogramming Lab, is doing all of that work, and we simply got a throughput problem. There's just too much work for those guys to do, and they are burning the midnight oil trying to get it done. It is not a technical issue. We're upgrading their tools. We're getting them better. They're getting more efficient, but we're just having to pump through and get as many mission data files out as we can with that one lab. Last comment, and then I'll stop for some questions. This program is still big. It's getting bigger. It is still very complicated. It has not gotten any easier since I got here about 3.5, 4 years ago. In fact, in some ways, it's getting more complicated with all the FMS customers and our partners starting to take delivery of airplanes and operating them in their countries. And the program's messy. It's just messy sometimes. You push on one thing on the program on this side, and it connects to 8 or 9 things over here on the program. And trying to keep all of that in sync it is a big challenge for both industry and the program office, and we don't always get it right. A perfect example of that is we have to have 23 airplanes in the full 3F configuration for the OT community to start IOT&E sometime in 2017 so they can do spin-up. Okay? Remember I told you about all those mods? I'm running out of parts. We're running out of parts to mod those airplanes. So we're going to have to rob Peter to pay Paul to get all of those OT jets in the right position to start spin-up in 2017 for the OT community. I got to take parts from the production line. I've got to take parts from spares kits. I've got to take parts from airplanes in the field today and put older, less capable parts on some of those training jets that aren't going to leave the country to harvest enough parts to get the OT community what they need. That's the level of messiness that comes with a program like this. You can't get, you wish you wouldn't have it, but you do, and you just got to work as best you can to work through it. The last set of charts I'm going to talk about has to do with that final little bullet where reality, you can go back, please. Reality on this program does not match the public perception or what's out there. More than any other program I have ever been on in my 25 plus years of acquisition, that statement is most true on F-35. And the gap between what is really going on and what people think is going on out there in the public realm is astounding, the size of that gap. I will give you an example. Today, I read an article in the UK by The Guardian. And one of the paragraphs in The Guardian, and I quote, "From structural problems that make it vulnerable to lightning strikes," we fixed that problem 2 years ago. Ironic given that it's called Lightning 2, yeah, chuckle. "To weight issues," we fixed that problem 9 years ago. In fact, we have been within 10 pounds of the A model and B model and C model weight on this program for the last 4 years. We have the most disciplined weight control program on the F-35 that I have ever seen. Let me continue. Bugs with its software. Okay, give them a check there. We just talked about some stability problems. And its complete lack of cybersecurity testing. I did over 300 penetration tests and cybersecurity tests last year alone on the entire weapons system. Okay? I am not allowed to field any portion of the F-35 weapons system unless it goes through a rigorous cybersecurity testing process that I don't get to put the check mark in. I have 7 government agencies called the COG and the CAG that look at the results of that and make recommendations to me as to whether the system is safe enough to put out into the field. We did over 300 of those last year. We're doing more now. What we're getting into right now, and maybe what they're talking about, is our ALICE system is broken up into pieces. We have individually cyber security checked those pieces, and in a lab, we have completed the end-to-end testing of that. But the OT community, like they should, wants to take ALICE and do an end-to-end cyber penetration test. We're on board. They're going to get it done this year. It's later than they wanted to. They wanted to do it last year. Lots of reasons why it was delayed, mainly the JPOS problem there, and we take that on our shoulders. But they're going to go do that testing. So it is articles like this today, written today, that create a gap between the perception of the program and the reality of the program. So indulge me for a minute. I'm going to give you what I call my myth busters. Okay, let's go. And I'll take only about 2 or 3 minutes to get through them all. Some of them are a little humorous, some of them are not so humorous. First, F-35 is still experiencing schedule delays and cost overruns. I think we just talked about that. All the major milestones are still intact. IOC dates, start of OT, either the objective date or the threshold date, the end of SDD, the completion of flight test, they're all within a threshold and the objective range of the plan that was put in place in 2011. We already talked about costs. Next one. Program has insurmountable technical problems and challenges like we talked about here. We have a pretty good track record of fixing things. 2 years ago, if I was standing here, instead of talking about ALICE and stability on the radar and the software, we'd be talking about the helmet and green glow and swimming and latency and 4 or 5 other things that were wrong with the helmet. We're not talking about that today because the Gen 3 helmet's out in the field and it's working magnificently. We talk about lightning. We're not a lightning problem anymore. We talk about an engine fire that happened 2 years ago. The fix is in the production line. We've retrofit 80% of all the airplanes out there with the new fix on the engine. The engine's performing beautifully. So there's an awful lot, there's an awful lot of instances where, yeah, we indeed had problems on the program, but our track record is that we took it on the chin originally, we got up from the mat, and we fixed it. I'll just give you a few more. The hook on the C model. Goodness gracious, we tried 8 times on the first design of the hook to catch the cable on the ground on a ground test. We missed it 7 times. A year and 2 months later, after we redesigned the hook, we went to a large deck carrier for the first time, and 108 times we tried to catch the wire, and we caught it 108 times. 100% boarding rate on the very first DT developmental test on a large deck carrier. Unheard of on a program, but people still talk about hook problems and things like that. So the perception there is insurmountable problems. The fact of the matter is we're going to have more problems. In the next 2 years, we're going to find more things wrong with this airplane. We're not done with development. Hell, even after development, we're going to find things wrong with the airplane because the OT community is going to stress the airplane. The warfighter is going to stress the airplane. The mark of a good program is not that you don't have problems. It's that when faced with problems, you fix them and you keep the program moving along and don't let it get derailed. Next chart. We talked about that $1 trillion life cycle cost estimate. Not meaningful for me at all. Boy, if anybody could tell me what the price of fuel is going to be next year, never mind 60 years from now, and oh, by the way, that's a huge input into that. If anybody can tell me what inflation is going to be next year, never mind 60 years from now, because that's what those are the major things that sway the $1 trillion 60-year estimate, whether it goes up or down. Not what's really important to me, what we're doing today to drive cost out of the airplane. Next one. Other countries losing faith in the program. Okay, so I'll address it directly. Denmark's going to make their decision probably in late spring, early summer. I think the F-35's got a pretty darn good chance. Okay? Canada, a new government. They are doing their due diligence. Any new government would want to make sure that the resources they have match their strategy and match what they're going to buy. You would expect that of our government. So with the new government in Canada, they've taken a pause. They are taking a look and trying to match their resources to their strategic needs to what they're going to buy. They're still partners on the program. They're still paying their bills today. Okay, they just haven't committed to buying any airplanes. My job is just to provide them the best information. Our job is to provide them the best information we can and let that process work out. Okay? I already talked about we have other FMS customers on the horizon. So the fact that people think that people are losing faith in the program is not quite accurate. Okay? Some of those things are politically driven. Others of those are just governments doing what governments need to do. Next chart. Yeah, this one's always one of the big fun ones because we could talk for days about this. That the F-35 isn't as good in the close air support role as X airplane, or it can't dogfight as good as Y airplane. Here's what I can tell you. It's a multi-role airplane. It does an awful lot of things very well. It may not do any one unique thing superbly other than what I wrote down right there. And that is, it's the only airplane we have today or are going to have in a very, very long time that can go into heavily defended areas, survive, put bombs on target, or in an air-to-air role, be the first look, first shoot, first kill capability against any airplane in the world. Don't listen to me. I don't want to stand up here and be a salesman. That's not my job. Go talk to the guys that fly the airplane. Go talk to the guys who are actually out there today, the Navy pilots, the Marine pilots, the Air Force pilots, the partner pilots at Luke, and ask them what airplane they'd like to go into combat with in the next 5 or 10 years and see what they say. And oh, by the way, if you're not in that denial threat environment where it's got to be stealthy, you can load this thing up with 15,000 pounds of ordnance on its wings and it's a truck. It will go a long way and drop a lot of ordnance if you don't need it in its stealth mode. Okay, next. This one I got when I was in Australia a few weeks ago. we do not need an internet connection to launch and fly the F-35. It makes it easier if Alice is connected in a network way back to industry, so that when we order parts off of the internet, we can automatically charge up the supply chain to do things. But if you don't have that connection, you just go back to doing things the way you used to do it on legacy airplanes, where you make phone calls and you work supply chain things. The airplane can launch every single day without Alice. All you need is a PMA computer to hook it up, and you barely need that, because the airplane in its pre-flight will tell you if it's okay to fly or not. All those ancillary things that you need the network for are all automated ways of doing what we used to do with pen and paper and pencils and phone calls. So the airplane will be fine if you cut off any kind of the network or internet connections. It'll just be a little bit harder, and you'll just have to revert back to some of the legacy ways of doing business. Next. We don't have a bigger problem here with noise in the U.S. with our services as we do in some of our European partners countries, but they're very concerned about that. I have done 2 separate, fully comprehensive noise tests on the F-35 in the last 4 years. I have the data. I can show everybody the data. This airplane is no louder, or actually in a lot of instances quieter, than legacy airplanes. The only condition where this airplane is 2 decibels, and oh, by the way, a human ear can only tell the difference between loudness at about 2 to 3 decibels. So 2 decibels higher in afterburner on takeoff. That's it. Everywhere else, it's quieter than legacy airplanes. It makes a lot of sense. The airplane's really stealthy and very, very drag resistant. So you put an airplane that's very draggy next to an airplane that's not very draggy, and you try and fly those in the same conditions, well, the F-35 needs a lesser power setting to maintain those conditions. Lesser power setting, less noise out the back. Makes sense. But people think it's louder. They think it's louder because it has a rumbling sound like an F-4. Anybody here who knew what an F-4 sounded like compared to the squeal or the whine of an F-15 or an F-16 or a Super Hornet will tell you that an F-4 sounded different. It was deeper, and you felt it here instead of here. That's the F-35. The F-35 has a rumble to it, okay? It's not that it's any louder. It's just that it sounds different. Next. Already flying with outdated technology. I guess this one came from our EOTS discussion, where there is a new generation of EOTS out there. Yeah, we're about a half a generation behind on our EOTS. But at some point in time in a development program, you've got to draw a line, you've got to integrate with the sensors and the capability you have at that moment, make it work on the airplane, and then plan on upgrading it through a modernization program. And that's what we plan on doing. The airplane has great growth potential, and somewhere in the 2022-23 timeframe, we are going to switch the main computers on this program to modular open system architecture. And when we do that, adding sensors and adding capability is going to be a whole lot easier. And that's part of our upgrade plan in our follow-on modernization. Next. This is another one that comes from some of our Pacific customers because they have the tyranny of distance, particularly Australia. The airplane can go a long way, folks. In stealth mode, it has over 1,200 nautical miles of range. In its stealth mode, it has somewhere on the order of a 600 nautical mile combat radius. The C model is actually even more because it carries more fuel. It has a bigger wing. B model a little less because it carries a little less fuel. But the airplane can go quite a distance and get the job done. Okay, next. Yeah, so this one was supposed to be one of those humorous ones. We're in report season, as we call it, in the F-35 world. We got the DOT report that came out. We've got the GAO short report and long report coming out. We get the DOD-IG quality reports that come out. Congress is going to do an Alice report that's coming out pretty soon. Every one of my partners does a financial audit once a year, as well as our FMS customers. So we're probably one of the most heavily scrutinized programs ever. And I'm not complaining. I'm not standing up here to complain about that. I'm just telling you that that's a fact of life on the F-35 program, and my team's gotten used to it. We get used to it. We don't like it. Sometimes it draws from our efficiency of getting things done, but it's what has to be done for the biggest, most expensive program in DOD, and we understand that. We just wish that we could figure out a way to do things a little more combined, maybe 4 or 5 partners doing an audit together, or maybe the U.S. Navy and the Air Force doing an audit together. Those sometimes seem to be a bridge too far, even though they seem rather obvious or easy. And last, before I open up for questions, having the F-35 program office in D.C. is a good thing. It's not. But to mitigate all your fears, it's not going anywhere. I have asked many, many times, and the answer is no, hell no. And you can understand that. You can understand with the international implications, with the political implications, with the money we spend on this program, you can understand why this is probably where the leadership of the department and the partners like the program to be. It just creates another level of complexity for us, because every time an FMS customer or a partner's senior leaders come to DC to talk to our senior leaders, if they're involved in the F-35 program, hey, let's just go by the JPO and see what's going on. And so we get a lot of that. If I was a program office at Wright Pat and Congress needed an answer, Congress would pick up the phone and call the legislative liaison folks. They'd pick up the phone and call the headquarters at AFMC or at LCMC. They'd pick up the phone and call the program office. And about 3 or 4 days later, a point paper would be written and the answer would be given to the Congress. That's not what happens on F-35. What happens on F-35 is somebody gets the Rolodex out and dials JPO, General Bogdan. Come on over and give us a talk. Come on over and let's have a chat. So my team spends an awful lot of time in the AOR here communicating. And that's okay. It's part of what we do. It just adds another level of complexity. And what it does is it creates, in some ways, because we communicate to so many people at so many different times, sometimes it creates a gap in what people know, and then in that gap, then they put their own thoughts and ideas in there, and we got to try and fight that. So I'll stop there. I got about 10 or 15 more minutes of Q&As. I'm sorry I talked a little longer than I needed. I'll try and be as open, as honest as I can, and I'll let Mr. McAleese decide who's going to ask the questions.
Sir, I assure you, you are among friends. So the floor is open for questions.
Hi, Lara Seligman from Defense News. So you mentioned the software stability issue, and that you're going to get the fix or the new software load flying on operational jets in April. You've said before that if you don't get this fixed by May 1st, that puts the August 1 date at risk. So that doesn't leave a lot of margin. So what's
on this program, 1 day is margin for me.
But so what? How confident are you that you can fix the software stability issue in time to meet the ILC target? And then I do have a second question, which is, can you give us an update on the status of the new lightweight Gen 3 helmet?
Yep.
Thank you.
On the stability issue, you're right. We need that fixed to be productionized and out into the field in the early May timeframe, not to affect 1 August. But as I told you, the long pole in the tent for Air Force IOC right now is not software, it's Alice. So they're both vying for who's going to be later. I personally think that we will get the stability fixed in March and in April, and we will move on. So I do not think that will impact 1 August. The second question was about the helmet. So very broad brush, very quickly, the escape system on the airplane today has a restriction that any pilot, male or female, that weighs less than 136 pounds cannot fly the airplane. The reason for that is threefold. The primary reason is because we believe that a person that weighs less than 136 pounds has a neck that is not as strong as someone above 136 pounds. And because of the forces during ejection, Some of those caused by the seat and the parachute itself, and some of those caused by the fact that the helmet weighs too much, create stresses on the neck of that lightweight pilot. The airworthiness authorities thought, not a good idea, we'll just put a restriction there. We have flight tested and figured out the fixes to the seat, and those are going to be ready for incorporation into the production line and retrofit by about November of this year. I took a briefing about 2 months ago where we were trying to get the helmet to remove 6 ounces. That's how much we have to remove from the helmet to get it within the weight. The helmet weighs about 5.1 pounds right now, the Gen 3 helmet, and we got to get it down to about 4.6 to 4.8 pounds. That schedule showed me that that helmet wouldn't be ready until late 2017. That was not good enough. So I sent the team back. The good news is the team did a lot of hard work, industry and the program, than 136 pounds with the lighter helmets at first, and then we will continue to produce from November of this year on the lighter helmets for good. Concerned, it was too heavy, and what was a concern? The visor on the helmet is manufactured to very precise tolerances because it's like a screen, it's a display. What we planned on doing was there was a second visor that was a darker visor that came down, so you were actually carrying on your helmet 2 visors. Well, if you need to lose weight on a helmet and you don't want to change a whole lot of things, one thing you can do is remove one of the visors and now have the pilot, just like our legacy airplanes, put either a dark visor or a light visor on. Taking that visor that is manufactured to very precise levels and making it removable and having the pilot be able to put that on and make sure that it's aligned so that he sees right is a manufacturing, difficulty. And they were saying that it was going to take 2 years to figure that out. They found some added tooling. They got some smart people, manufacturing folks on the job, and they figured out a way to do it in a year instead of 2 years.
Hi, sir. Colonel Charlie Wells from the U.S. Army. We've had a huge effort in Army acquisition to try to garner test efficiencies. And given that you've probably got the largest and most complex operational test in the DoD, have you been able to drive any test efficiencies for your OT? And also, I think just as important, how receptive has DOT&E been to provide sufficiency, whether it's a computer simulation or a robust DT that can be provided as part of the body of evidence?
Yeah, that's a trap of a question, so I'm going to be a little careful here. We do have a very big OT program. Rightfully so. This is not a single airplane program. This is like 3 programs put in one. So when you take it from that perspective, the size and the time and the work going to be done on OT is representative of 3 airplane programs instead of 1. We have partners who have airplanes and resources that are going to be participating in OT. That's good. That helps the U.S. reduce its resources necessary for OT. What I would like to see is a deeper integration of those partners in OT so that they can do more and share, and we can share more with them, and they can share more with us. I think that would make OT a little bit more efficient, to be quite honest with you. Other than that, we're working pretty well with the JOT, the Joint Operational Test Team on the program. We are going to use modeling and simulation to validate some things. That in and of itself is risky because you got to make sure that the models are right and the bar set for that is pretty high. But once you can get to that level, then those models and that analysis can become very valuable, not only for OT, but for the future. So we're endeavoring to try and meet that pretty high bar set by OT.
General, back here, thank you. Sandra Irwin with National Defense. Lockheed Martin Aeronautics just announced some significant layoffs. Did the company discuss with you what impact, if any, that would have on the F-35 program? And as a subset to that question, do you view that as the type of measure that you want to see in industry to help reduce costs in programs? Thank you.
Yes, Lockheed Martin did discuss it with me in advance. Yes, I understand why they're doing it. and I welcome them and any other industry partners who recognize that to remain competitive and to give the government a best value, they need to drive their costs down. I don't want to see costs driven down at the expense of quality or schedule, and they have assured me that that won't happen on the F-35 program, but we will watch that carefully. But yes, if it's going to drive costs down with Lockheed Martin Aero, then I am all for it.
Hi, Jen Damasio with Aviation Week. Over here.
Oh,
Hi.
sorry.
I wanted to follow up about the potential delay to IOC regarding Alice. Is any of that related to what Congress was asking about last year? They said there was something like, I think, an 80% or 85% false positive reading that Alice was giving. Is that improved at all? And then a second question on kind of retrofitting and doing the mods. How much is that going to cost?
So on the Alice question, no, the delay or the risk to Air Force IOC for the next increment of Alice has nothing to do with the false positives. That has gotten much, much, much better. I don't have the facts or the data with me here, but I can tell you that 85% false positive was another one of those gaps between reality and perception. There are a number of times when the airplane tells you that there's something wrong with the airplane. Okay? Some of those we know today because we're not finished developing the prognostics on the airplane that they're not going to tell you the right answer. So we filter those out. Okay? So the number that was given on 85% false positives was the whole body of things that the airplane tells the maintainer he has to look at, recognizing that a huge portion of those we filter out because we either know that system isn't up and running yet because we haven't developed it, or it gives a false indication. When you start narrowing that down, you're down to maybe 2 or 3 or 4 per sortie incidents where the maintainer has to check to see if the airplane is actually broken or not, and in more than half those cases it is. So when you whittle that down, it's a very, very small percentage, and no, that does not have anything to do with the risk we see in Alice 202. The risk we see in Alice, the next increment for IOC, has everything to do with the back end of Alice. Alice today on the back end connects to Lockheed Martin, their ERP system called SAP, and eventually it will connect to Pratt & Whitney's ERP system. Today, the engine information in Alice is separate from the rest of Alice. We are trying to bring in Pratt & Whitney's information about the engine into Alice. That is proving to be very, very tricky. Okay, that's one. Two, the back end of the system that connects to Lockheed also now has to be adjusted because we are introducing new capability called life-limited parts tracking. So each part on the airplane has a certain life. And if you move that part from airplane to airplane, you got to be able to track how long that part has been flying around so you can be assured that whatever airplane it's on, when it comes up to its life, you either got to do an inspection or take it off. That is a very complicated undertaking when you're going to have 3,000 airplanes out there and you're going to have a global spares pool. We're going to implement that in this next increment of Alice, and it requires some serious changes on Lockheed Martin's SAP system. Both those systems, Pratt's and Lockheed's, are proving to be really difficult connecting with Alice. That's where the risk is in Alice. And remind me of your second question, because I got long-winded on the first one. Oh, yeah, like I said, I think today, unmitigated, without doing anything, we're probably 45 or 60 days out of bed. That still puts you in the September, October timeframe, and the U.S. Air Force has said anytime between August and December is okay for IOC. So I do not see the threshold date of December at risk at all. But for my team, we're focused on 1 August, and if we miss 1 August, then that's on us.
My other question was on the cost of mod.
We can give you a cost estimate on how much it's going to cost to mod an airplane to a certain level. That does not necessarily mean that's what the services want to do or the partners want to do. It's their money. So I have presented to them a plan over the next 3 to 5 years that shows how we can take every airplane we're producing, right up until that Lot 9 airplanes, and bring all of those airplanes up to a full 3F capability. And we have those cost estimates, not in aggregate, but based on who owns the airplanes. And it will be up to the services to decide if they want us to implement that. Suffice to say, it's in the hundreds of millions of dollars for these U.S. services, because there's a couple hundred airplanes in that. I can get you some of the exact numbers. They're estimates, mind you, and that's a choice that the services have to make on how many airplanes they want to bring up to that configuration level.
General John Turpak, Air Force Magazine. Now that the Air Force has announced that Pratt & Whitney won the B-2 engine work, do you anticipate F-135 cores will be increasing in number and you'll be able to get some benefit out of that, some reduction in price on your engines?
Yes and yes. I think there's some things that we learned on the F-135 engine from Pratt & Whitney that will greatly benefit the long-range strike airplane. And at the same time, I think that Pratt & Whitney ought to be looking to drive the cost of the F-135 engine down now that they have that other business. And I would expect them to.
Thank you.
General, Marcus Weisgerber in the back, 1 o'clock. You're 1 o'clock. Keep going.
Oh, I got you.
Okay. There's been a lot of talk today about 6th-generation fighters and possible collaboration between the Air Force and the Navy. As somebody who's led this program for the past 4 years, can you maybe talk about what advice you would have for the people working on that program moving forward?
Yeah. Joint programs are hard. I'm not saying they're bad. I'm not saying they're good. I'm just saying they're hard. And one of the main reasons why they're hard is because those folks that are teamed together in a joint program must be willing to compromise. And man, is that a hard thing to do when you're spending billions of dollars. You want what you want, or hopefully get what you need. And so my best advice to the Navy and the Air Force is, given the lessons we've learned and how hard it has been on the F-35 program to compromise, you ought to think really hard about what you really need out of a 6th-generation fighter and how much overlap is there between what the Navy and the Air Force really need. And oh, by the way, whatever that estimate is today, it's going to change. We started this program thinking it was going to be 70% common between the A model, the B model, and the C model. Today, it's 20% common. So you got to think. You got to think through that. I think we're running out of time. Yeah. Okay.
Department budgets for both modernising existing fighters